Okay, cool. Yeah, I want to get started, Akash?
Yep. Can you see my screen?
Yep.
Yeah. So, so today we'll be continuing on this paper called A Survey on Large Language Model Based Autonomous Agents. Last week, Ashwarya covered the design aspect of this paper, the section 2, which was the different ways people are building, how are these autonomous agents being constructed. And a lot of discussion was around their design, like they generally have a profile section, memory module, planning module, and an action module. This week we'll be focusing on two things. The Yeah, I'll go to section 3. Yeah, so this week we'll be focusing on how different how how are these applications being used in different sectors, and how can these applications and these agents be evaluated. So yeah, first of all, yeah, so these new LLM based autonomous agents are being used everywhere that we know of, like any industry, um, or it's like the basic intelligence that is provided by these LLMs is being used in each and every industry. So this survey paper then focuses on different fields that it is being currently used on. So in the field of social science, you first see this being used in the field of psychology, where LLMs are being used to simulate psychological experiments. And yeah, they find that um, that the LLM based agents show a psychological tendency to prioritize self interest over coordination. So in each section, you will notice that there are a lot of paper that are linked. So each and every experiment in itself is quite interesting. And as last week, Aishwarya also mentioned that we should like finalize few papers uh, in the few papers that we can later study. So yeah, so I'll keep highlighting the interesting ones in the in between. But yeah, this paper contains a lot of very interesting references which we can dwell into later also. So continuing on the use of LLMs in social science, the authors also mentioned that how it is being used in political science and economy. Uh, so a very nice, interesting use case is that LLM-based agents can be utilized for ideology detection, predicting voting patterns. So for example, in these for these references, that these agents are utilized to analyze partisan impressions and explore how political actors modify agendas, and among other applications. So in a way, using the profiling that was discussed last week, we can give certain traits to these LLM agents, and they can act out certain scenarios or experiments, giving different different kind of profile, like giving different kinds of profiles to an LLM agent, and that helps in a way to reenact these experiments. Yeah, so another place where it is being used is social simulations. So LLMs are being used to simulate a range of social phenomena like the propagation of harmful information. Now, if you want to replicate such scenario in real life, it is highly dangerous because there are real people involved, and you don't know how one information can transform into something else, and how negative information can affect people. But for such scenarios, you can easily replicate them using LLMs without any thought that it might cause real harm. So another example would be like this paper simulates an online social community and explores the potential of utilizing LLM-based agent simulation to add decision makers to improve community regulations. Now that you can, experiment with these social simulations, then it gives the decision makers a better idea of what policy might work for their use case. And this this was very interesting, that Social AI School employs simulations to investigate fundamental social cognitive skills that manifest during the course of child development using an LLM. So it was quite interesting. Another use case in 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 social science is jurisprudence. Basically, the LLMs are used to simulate the decision making process of multiple judges, so they can be used in legal decision making, facilitating judges in rendering more informed judgments. So this is another social aspect in which there has been active use of LLM based autonomous agents. And another interesting part is where social science research assistant. So the idea of assistant is quite recurring in this paper, as in the idea is that to somehow enhance the capability of an individual using these agents, and later we'll see in engineering how they are again using in tandem with the person using these autonomous agents. So yeah, in social science research assistant, LLMs are playing the role of literally the role of research assistant. And yeah, so using LLM based agents in such situations have two primary concerns, that are bias and toxicity. So these LLMs are trained from real world data set, and which makes them susceptible to inherent biases. And yeah, so whenever such LLMs are used in these cases, like when you're trying to create a simulation of the population, then these bias might be present in the agents that are given that kind of profile. Yeah. So next we'll see how these agents are being used in the field of natural science. So documentation and data management is quite important in the natural scientific research, because a substantial amount of literature and data often necessitates meticulous collection, organization, and extraction, which uses a lot of human resources. So they're trying to automate this part using the LLMs or LLM agents. Another theme, as I said, right, assistant. So natural science experiment assistant. These LLM based agents can operate autonomously, conducting experiments independently. So yeah, to give you an example, this paper number, reference number 7, it is referred a lot of time, and it will be really interesting to cover this next week. So it introduces an innovative agent system that leverages LLM to automate the design, planning, and execution of scientific experiments. So yeah, so as an assistant, it is helping in the it can help in the design, planning, and execution, something like what MetaGPT is doing for the is doing for the process of engineering. So coming up with what sort of steps need to be done and what all things need to be done, those kind of planning. And again, a very huge use case of LLM is in natural science education, because these LLMs are quite an exciting educational tools that can offer real-time question answering and knowledge dissemination. And since these LLMs know pretty much everything, you can ask them about coding or any specific subjects, and they can give you very detailed answers about concepts. And if you're not sure you're able to understand that concept, you can ask it again to give more example also. So these LLM agents are really good for educational purposes. Again, since you are using them for educational purposes, the LLMs themselves may be susceptible to illusions and other issues, which can often provide erroneous answers. So yeah, so again, you have to use them with the word of caution. Now, how they are being used in the field of engineering. So we all have seen in the CS community that libraries like MetaGPT, GPT Engineer, like these things being used in computer science, but other than that, it is also being used in civil engineering. And LLM based agents can be used to design and optimize complex structures such as buildings, bridges, and roads. And the thing is that you can do this in an interactive way. And this shows the potential of human AI collaboration in engineering design. So both human ideas and machine ideas coming together. In computer science and software engineering, these LLM-based agents offer potential for automating coding, testing, debugging, and documentation. And I suggest that we look into all these papers that they have referred here, because yeah, let's for an example, for chat dev proposes an end-to-end framework where multiple agent roles communicate and collaborate through natural language conversation. Another example is of tool bench that can be used for tasks such as code auto completion and code recommendation. Meta GPT we just discussed. So there's a lot of development in this place, and it would be really nice to cover all these paper, or at least give a summary of at least in how these agents are being used in CS and software engineering. Another example is how LLMs are being used in aerospace engineering. So these LLM-based agents are being used to model physics, solve complex differential equations, and optimize design. Yeah, and in industrial automation also, they can be used to achieve intelligent planning and control of production process. So here they work with the idea of a digital twin, and the yeah, so yeah, so these digital twins, right? These agents can coordinate a series of atomic functionalities and skills to complete production tasks at different levels within the automation pyramid. So yeah, so continuing on robotics and embodied artificial intelligence. Um, when it comes to robotics, the focus of using LLMs is on enhancing the autonomous agent's abilities for planning, reasoning, and collaboration in embodied environments. So, to take an example, like 106 and 143 employ autonomous agents for embodied decision making and exploration guided by internal world models. Um, yeah. So, yeah. So this demonstrates the promise of natural language understanding, motion planning, and human interaction for real world robotics. As capabilities advance, the adapted autonomous agents may accomplish increasingly complex embodied tasks. Other than that, there has been a constant, uh, effort to build something like a general autonomous AI agent, something like a predecessor of artificial general intelligence. And again, a lot of things are being built in this direction, like LangChain, which everyone has, everyone knows, is like an open source framework which helps in designing different kinds of autonomous agents for a use case. Similarly, there is something called XLang, which comes with a comprehensive set of tools and a complete user interface, and supports three different agent scenarios, namely data processing, plugin usage, and web agent. Yeah. AutoGPT, another famous one, is a fully automated network agent that simply sets one or more goals and automatically breaks them down into corresponding tasks and cycles. So this is represent all the papers that they have mentioned based on which domain they are working in. So that's um, yeah, another good example is that of GPT Researcher, which is an experimental application that leverages large language models to efficiently develop research questions, trigger web crawls to gather information, summarize sources, and aggregate summaries. So, yeah. So in summary, the authors mention that as these LLMs continue to advance in their reasoning and generalization capabilities, uh, they expect that the symbiotic human AI teams will unlock new horizons and capabilities in engineering, innovation, and discovery. So uh, a lot of things that were covered in this section were again in there was a symbiotic use, so that the human gives an idea, or um, and machine helps with it. So yeah, any questions till now? Hello.
Yeah,
Yeah,
I think we're good. I think we're good. Yeah.
yeah, this paper does not have like something like a concept. It's just like a reading through of what all is being presented.
Yeah, I mean, I think the one so far it's domains, right? So like maybe the section 4 will have more things to discuss.
Yeah, section 4 is also similar. It's talking about evaluation, and there is nothing new concept or anything. It's just they're discussing what all has been implemented till now.
Yeah, let's go with. I mean, I think eval is like pretty, like obviously very important, right? Have you? Yeah, we can chat about it. But have you guys also tried some of the systems out there? Let's go. We can discuss it after you cover this section.
Sure. Yeah, so so now in previous section we talked about how these agents are being used in different areas, and before that we discussed in last week's meeting we discussed the design. Now the authors discuss about how these agents are being evaluated. So there are two commonly used evaluation strategies, which are subjective and objective evaluation. So talking about subjective evaluation, through subjective evaluation, the agent's intelligence and user friendliness cannot be measured by a quantitative metric. So to test out these things, the evaluation has to be subjective. Now, how can you do subjective evaluation? You can do them either through human annotation or via a Turing test. So in human annotations, the human evaluators directly rank or score the generated results of the LLM based agents based on some specific perspective, like is it helpful or whether it is user friendly. So yeah, other ways to do a Turing test, basically where a human is asked to distinguish between an agent and a human behavior. And both of these things, since there's a human involved, human evaluation, subjective evaluation suffers from expensive costs, low efficiency, and population bias. So, yeah. Because there are certain things that it's very hard to get them in an objective evaluation, like helpfulness, user friendliness. So subjective evaluation is here to stay, but they are quite costly and not really efficient. So when it comes to objective evaluation, uh, quantitative metrics enable clear comparison between different methods and tracking of progress over time, and these results are more objective and reproducible. So there's a great importance of having these objective evaluations also, because if we are working on a model or an agent, we can clearly see how it is improving in different aspects through these objective evaluations. So to do these objective evaluations, first you need metrics, like what metrics are you going to track. And yeah, so the metrics are usually of three types. Task success metric, which is basically something like a success rate or a reward/score. Another kind of metric can be human similarity metric, where they are trying to see how good the agent's responses mimic that of a human. And examples like trajectory and location accuracy, dialogue similarities. So they are being checked against human scores for that. Efficiency metrics include development cost, inference speed, which is a very important thing. Yeah. So these are the major metrics that are they're the major classes of metrics that are being used to evaluate these agents. And there are different strategies, like which strategy do you use to evaluate your agent. One such strategy is environmental simulation, where like if you're trying to look for metrics like task, success, and human similarity, you will give the agent the capability to act in an environment. So there you can check by the agent's performance how good or how close it is to a human. Another way to do this is via isolated reasoning. So in this method, the researchers concentrate on fundamental cognitive abilities by employing limited tasks such as accuracy, passage completion rate, and elevation measures. So basically checking its performance on a very specific use case or a very specific problem. Social evaluation directly probes social intelligence using human studies and mimicry metrics. Multitask uses suites of diverse tasks from different domains with zero and few shot evaluation. And the last one of software testing, they check how LLMs for various software, they use LLMs for various software testing tasks. So basically, strategies refers to how do you, like, what are the what are the different methods in which these agents are being, evaluated. Benchmarks. So benchmarks is very important in our field. So many papers construct these benchmarks with a data set of tasks and environments to systematically test these agents. And there are a lot of benchmarks out there which track and see what kind of performance these kind of agents are giving. So there are a lot of examples of that. So here they have also mentioned about Socket, which is a comprehensive benchmark for evaluating the social knowledge capabilities of large language models. So each of these benchmark will focus on different aspects. So ClemBench is a game-based approach for evaluating chat-optimized language models. So yeah, depending on the benchmark, you can test out these specific capabilities of these LLM agents. So while current techniques have limitations in measuring general capabilities, objective evaluation provides a crucial insights complementing human assessment. So yeah. So broadly, just to summarize again, there are two ways to evaluate an agent: subjective and objective. And in objective, you are usually trying to use a metric to evaluate the agent, and then you employ a strategy of what should be done so that agent can act. And then there are different benchmarks which help us identify the capability of these agents in specific areas. Then authors discuss about related surveys that are also talking about these things. The most interesting part is challenges, because now that they have mentioned where all they're being used, they now highlight where they are lacking. So when it comes to role-playing capability, like the earlier scenarios we mentioned that are where these agents are being used in social science experiments, one key fact arises is that there are still many roles and aspects that that can be hard for LLMs to capture. To begin with, LLMs are usually trained based on web corpuses. Thus, for the roles which are seldom discussed on the web or a very newly emerging role, LLMs may not be able to simulate them well. So again, it's an inherent limitation inside the capability of current LLMs, because if something is not discussed widely on the web, it might be hard for the LLM to assume the role or profile of that kind of scenario. Another issue is generalized human alignment. Basically, like with ChatGPT, what we saw was that the LLMs are usually fine-tuned to align with correct human values. So if we want to be able to, to replicate or simulate a population, then in those use cases, LLM should be able to get a negative persona also. Some sort of negative aspects of human also should be captured in the LLMs. Because now all the good human traits are being taught to these LLMs using human examples, like to be polite and to be correct, to be humble. That can have an effect when you're trying to simulate a population, because in a population there are different kinds of agents. So this generalized human alignment does cause some issues, because it hampers these LLM to take out different kind of roles which include the negative aspects of human nature. Another issue is of prompt robustness. So if we are using these LLMs to let's say get a SQL query and retrieve something from database, then the mechanism for converting that natural language prompt to that SQL query should be very robust. And that is a issue that is there, that previous research has highlighted that the lack of robustness in prompts for LLMs, as even minor alterations can yield substantially different outcomes. That is so true for all the LLMs that are out there. And developing a unified and robust prompt framework that can be applied to various LLMs is an important yet unresolved issue. So for each new LLM, you have to manually try different kind of prompts before you can be able to work with them well. Hallucination needs no mention. It's a fundamental challenge for LLM. It's a problem that is there and people are looking into how to resolve it. Next, they talk about knowledge boundary. So this is a very interesting point here. So they're highlighting, let's say you are using LLM agents to simulate a population. Now the thing is that LLM in general has much more knowledge than the person they're trying to imitate. So let's say if they're trying to imitate a normal person, that normal person does not have that much access to knowledge, like how much big model like GPT-4 has in its own weight. So when you ask them to simulate in that way, if you ask them to simulate a normal person, it is quite possible that the true knowledge boundary between a normal person and a very big heavy model like GPT-4 will not be there, because even if you're asking it to simulate a normal person, that person will have the common sense reasoning of the model itself. You can't I'm not sure if you can do this, but you can't say that you tell a model to act with lower IQs or something like that. So there's this issue of knowledge boundary when using LLMs for simulation. And again, efficiency, because of its autoregressive architecture, LLMs typically have slow inference speeds. So these slower inference speed is again an issue, because if you are looking for something very live and fast, these inference speeds are a blocker. And yeah, that's it for the paper. Any questions? Yeah, that's it from my side. Thank you, guys.
Yeah, thanks, Akash. I think probably what we can do next time is I think the first half of the paper kind of dives deeper into the theory of how these agents are set up. So maybe we can choose a few from there and spend more time on like the memory parts and so forth. What do you guys think? Because I think that was more of the conceptual framework for how agents are built, which I think we can spend more time on.
Yeah, let's finalize some papers, right? Even in the later part of the paper, there are some things that would be interesting to cover. So
Yeah, we can do that. I'll go through the first half and then we can do the same for your part.
yeah, sure.
Awesome. Cool. See you all next week then. Yeah, we can just do it in the channel. I think that might be better. I don't have a list right now.
Sure. Okay. Thank you. Bye, guys.
Bye.
Bye-bye.